Hello, good evening. My name is Iman. I'm going to be talking about the Biomedical Engineering course in DCU. I'm trying to wait for a few more minutes just to see if anyone else wants to join. Um, Sorry. So if you have any questions, like have them in the chat, and I will cover all the questions once I'm done with the complete presentation. But I will make sure I go through the chat to see all the questions afterwards. Okay, I'll probably just start now. So yeah, hi, I'm Iman. I'm going to talk you through the biomedical engineering course in DCU. I am a third year biomedical engineer, so I'm doing this for 3 years, and I think I'm well qualified to explain everything that you need. Right. So just to start off, just for biomedical engineering, these are the course details. So you need 531 points minimum. It's a 4-year course, level 8 placement, and has a placement as part of the academic grade. So biomedical engineering mainly focuses on using biology and science to apply engineering techniques into like the medical field. So we really focus a lot on biomaterials, like materials that are adaptable to the human body, making implants, transplants, artificial organ artificial organ technology, medical devices, tissue engineering. We also have some parts in rehabilitation and biomechanics as well as diagnostic technology. So this is also a talk to cover like the common entry side of engineering. So I'm going to do that now. So in the first year of engineering, all the mechanical and electrical engineering courses, so you have your mechanical and manufacturing, biomedical engineering, mechatronic engineering, sustainability, and electronic engineering. Everyone has the exact same modules or subjects in the first year. And some of the key ones that stood out strongly to me are your we have circuits, sorry, we have electronics, which is a class, like a module where they focus on teaching how circuits work, how to build circuits. It's really lab focused. So as a picture you can see here, it's a circuit that I made. The entire thing basically just controls the LED, but it is a bit finicky. The second one on the far right is like the year-long module we had in first year, which is the automated guided vehicle. And everything that's metal on that like machine is made by the students. So we had to design and build that. Everything, like all the wires, everything was done by us, and we were taught how to solder, how to attach things together. So they really focus on teaching you how to make things work and how you can do it yourself. It's also a really good way they do this because they want you to give everyone like an overall concept of what engineering can be like, so you kind of figure out what you like and what you don't like. Like I knew from first year that I did not want to have anything to do with electronics at all. I just it wasn't working for me, so I made sure I chose a course that was fully mechanical because I didn't want to do anything electronic. Then once you get past first year, at the end of first year, you should choose what course you want to go into. I chose biomedical engineering. So then these are the modules we have in biomedical engineering. So we have how life works, circuits, math, mechanics of machines, thermodynamics, strengths of materials, design and solid modeling, thermofluid mechanics, human movement, and anatomy and physiology. When you do biomedical engineering, every year you will have at least you we'll have at least one biology module because it's biomedical engineering. So there will always be a biology science module. So you learn about the human body in second year, and as you progress, it gets more detailed and it gets more like in depth. But this boat you see here is a project we had for the thermofluids mechanics project. The whole basis behind it was to see how fast you can get the boat to cross a 2-meter tank of water. So we had to design, 3D print, model, and do a lot of testing all done by ourselves. It's all group work, but it's all done by the students, and then they grade you based on a final report and your final um like boat itself. And on the right, there's a tank support from a materials module. This module was focused on teaching us the different materials, how things work, what kind of things, how strong materials are, how weak they are, how flexible they are, testing and calculations for all these things. So it's a really interesting module. Now in third year that I'm in now, our main like project is what we nicknamed the fireman. Basically, it's a project for product design, and you build like a little robot that carries 500 ml of water up a 2-meter ladder, and you it's fully designed by the students. Everything that you see in this picture is from my group, and this is what he came up with. This is probably our third design, so it does take a lot of refining and trial and error. The image here is from SolidWorks, which is like a computer-aided design software that allows you to build and create all your like pretty much anything you want to make and made in there. But as you see here, modules we have immunology and cell biology. That's like the main biology module for third year. So it goes really in depth into like vaccines, immunology, how the body works, your immune system, and it's very decent. It's really interesting. Other key points in third year is your intra work placements, which is 6 to 10 months. Then depending on what type of course you're doing, the length varies, but I'll get into that a bit later. Fourth year modules, image processing, biomaterials, phase element analysis, heat transfer and fluid mechanics, operation, research methods, rehabilitation engineering, surgical device care, and fourth year product. So as you can see, it gets a lot more biology focused the higher up you go. So here we have like 3 biology modules, and there's a final fourth year project. So if you're doing the bachelor's degree, this will be your last year, and the fourth year project will carry a huge chunk of your grades for like that year. Now, I mentioned before intra-work placement. So basically, intra-work placement is what DCU does to get their students out into the field working. So you have either a 6 or a 10-month work placement, and you apply to a company, you have an interview, and they tell you if you got the job or not, and you go to work with them as an intern, but then you're seeing like you're on site most times doing all the work with them. So they're showing you exactly how it's done. And it's a really good opportunity. It happens in third year, which is my year now. So mine starts in March, but it's really good. I've heard feedback from older students, and they say that they go for intro and they either come back saying, "Oh, I love that work. I definitely want to work there when I graduate," or they come back and they're like, "I don't ever want to work here. It was horrible." But it's a good experience, but they all had a really good experience. Integrated Master at DCU. So this is when the bachelor's degree and master's degree combine into one degree, and that it kind of changes the course of your course. So basically, if you're doing a regular bachelor's degree, you have the 6-month intra placement. If you're doing an integrated master's, it's 10 months. And it's really handy because it allows you to have more experience because you learn more, and it's a 5-year course. And then instead of having to do the projects in fourth year and one in fifth year, it's just the one fifth-year project. And it's honestly, it's a really good option. I am doing it because it's just nicer like that for me personally. The only requirement that you have is you need to have an average of 50% overall in the end of year grades, but that's really just it. So this is just like a image of how the pathways work. So if you're doing just the bachelor degree, you go first year, second year, then up the upper pathway. So you do third year, fourth year, you graduate, and if you have a H22 minimum average and apply for a master's. If you're doing the integrated, you do first year, second year, H22 average, then you go third, fourth, and fifth year just at a go. I have the longer intro placements. So I personally just think it's the best route for me. Now, career-wise, once you graduate with the biomedical engineering degree, especially in Ireland, this is a big reason why I chose the course. Ireland has a lot of pharmaceutical companies, and which means that it's a lot of job opportunities once you're graduated. Like there are 2 different areas. Like there's the healthcare and there's more medical device companies. So like, but as you can see, there's a list of different job titles: clinical engineer, product development, quality engineer, and they're all just honestly really good and really interesting roles. DCU also has a really high employment rate for graduates, so the chance, just off the data, the chance of you getting a job afterwards are quite high, and there's always people looking for engineers in the medical like sector. Now, even if you do a biomedical degree, you can still get, for instance, a job that's more biology or a job that's more like mechanical engineering. So you aren't really just like stuck in one section. You gain the knowledge to be a bit more broad in what you do. So you can work in like just straight up medicine pharma, or you can kind of go more towards like manufacturing. Yep. I will take a look at any questions now. If you have any questions at all, just put them in the chat and I'll be happy to answer anything. Right, let me just check here. So we have how many points? So I asked that already. That's 531 points. Yes, there is also the requirement that you do need at least a H4 in math, or you can also have a H4 in applied math and a H5 in maths. Are any books required? How do we get them? So there are books required. A lot of them are available online. No, books aren't required. Your lecturers will say you should get this book. You can either buy them off older students, which is what a lot of people do because they tend to not be as expensive, or you can find them online when we still have to buy them online. There will be teachers that highly recommend a particular book, especially if they take a lot of their course content from that kind of book. So it is occasionally handy to like get a particular book. Yeah, yeah, yeah. Just entering engineering in DCU, all the courses have a math. It's the only requirement, but they all do have a math requirement. Does anyone have any other questions? It can be like about anything, if not just any engineering, or I can ask about stuff the university does as well. I can actually tell you about I am in the engineering society in DCU. I'm actually on the committee. So in this society, I don't want to sound like I'm tooting my own horn here, but I personally find it to be a great society because especially if you're new into engineering, you can come in and they're really welcoming, they're really helping in the first year. Everyone there has been through like has done engineering or engineering something similar, so they all kind of know anything you have to ask them. They will like answer any questions. That's why I personally it's my favorite committee. It's my favorite society just because the community is really nice and everyone is just really helpful. But there are also like a lot of clubs and societies in DCU, and they're just so many. There's like a lot of sports clubs and yeah, there's a lot of courses have clubs or societies related to like their faculty or their course as well. Yeah. If anyone has any other questions, feel free to ask. If not, enjoy the other talks that'll be happening this evening. Oh, work workload wise, engineering at least in first year is not that bad. You're not really doing a whole lot. It's a lot of lab work and project work, so you're on campus a lot, but it's not terribly intensive. Going into second and third year, second year, your workload is heavy. The flow is heavy. You have a lot to do. If you manage it well, perfectly fine. Um, if you don't, you are going to kind of struggle a bit, as I did. But overall, the workload isn't that bad. Third year is similar to second year because you're not on campus as much, but the quantity of what you're learning has increased. But I guess as most courses go up, that tends to happen for all of them. But as long as you keep on top of any work you get, you're honestly fine. And there is lots of help. DCU has a math learning center. So I know I used it in first year where I learned something in my lecture and I had no idea what's going on. And I go back to math learning center and somebody will help me kind of break down what's happening and they can explain to me. There's also an English writing center, I believe. I've never personally used it, but I have heard some really good things about it. DC has a lot of resources when it comes to helping students. And also lecturers are honestly just great. I've never had an instance where I've like emailed my lecturer and they said I can't help you. They always to give you suggestions, say, let's book a meeting, I can explain something to you. Is this field more practical or theory focused? Um, I would say it's honestly 50-50. Biomedical engineering, because you do so much biology, there is a lot more theory. Well, not a lot more, but there's more theory than, like, for instance, probably mechanical engineering has. We do have a decent amount of lab work, so a lot of your time is going to be spent doing lab work or like project work or group work. So it's theory focused where they teach you what you need to do, and you may think this isn't terribly relevant, but then they give you a project and then you can see exactly where you need to like use, for instance, this calculation that I thought was really obscure and it came up like the first thing on project research. So not terribly theory focused because it's a lot of calculations and math, but what they do teach you is quite relevant. It's quite relevant. And actually, speaking of projects, I think I mentioned this before, but a lot of the work you do, a lot of work you do is group work and it's lab work or like it's project work. So you're going to be working with people almost the entire time. They're very big on getting the engineers to learn to work together because you're hardly working alone in the field. So it's a lot to teach you how to work with people that you don't know and like team building skills and group work skills. It also helps take some of the pressure off some like bigger projects where it's not just you trying to do the whole thing by yourself. So you have people to rely on as well. Does DCU have links with employers? And if so, who would you have links with? I know DCU, because of the intra program, they do have a lot of links with employers because a lot of employers have taken students that are doing work placements from DCU and had them as interns. And like a lot of time, people will come back from their intra placements saying that they actually got a job offer when they graduate, they can immediately start working. So there is a lot of opportunities to get links with different employers because they've had so many past DCU students in there and they've had a good reputation. So for instance, when we have to do the intra placement applications for work, it's through a school portal. So companies put in applications for like what kind of student they would like or like what course they would like. And it all comes up on this big website and it's filtered and sorted depending on your course. So a lot of companies like to take students from DCU, which is why the employment rate for graduates is so high, which is honestly quite handy and it's a lot of stress taken off your shoulders because the school does help you when you're looking for work as long as you're a student. But yeah. And personally, I don't personally have any links with anyone because I haven't started working yet. So I can't really give you more information in that aspect. That is true. Yeah, if you were to check dcu.ie/intra, you will find probably everything you're looking for in that aspect. Yeah. But there are a lot of companies because the work placement takes place across, I think, almost all the courses that DCU has. A lot of companies have worked with DCU, and they have a lot of good feedback. What subject did I do? I I did high level. I had all high level subjects. I did maths, English, French, economics, physics, biology, and chemistry. So I had all three science subjects. I went to an all girls school, so like I didn't have any of like the more, I guess, engineering subjects. Like a few of people I know had engineering in secondary school, or they had like design technology. I really wish I had those because they just sound really interesting, but no, I didn't have a choice of those. But yeah, there isn't really the only requirement that you need is math. And like while having experience in some subjects might help you a little bit, when you're learning all the things for like the course, they go through everything with you, which is the main part of the first year. They have basic sciences, which is you learn chemistry, biology, and physics at leaving cert level. Not as in depth because it's a lot more general and it's a bigger like number of students, but they do go through the basics with you and you learn biology basics, physics basics, chemistry basics. It was also with that part of them trying to give you a wide range of subjects in your first year so you can kind of figure out what you would want to do in second year. Because like people who don't want biology don't obviously would think, oh, I didn't like for living certs, but I've tried it now I don't like it, so I'm definitely not picking biomedical engineering, for instance. The projects I completed. I can show you back. I can show you back. Sorry, I can go back on the slides I was showing. Let me see if this registers properly. Yeah, I'm just gonna quickly restart. I'm going to restart sharing my screen. Okay, no, it's actually fine. Okay, so I can just like have a go back over this. Basically, in first year, this robot that you well, robots I feel like it's not quite the word for it, but the little mechanical thing that you see on the right was the main project for the first year. It's called an automated guided vehicle and some logical project and technical drawing. Yeah. So they teach you when you first start this module, you actually start out with they give you like a little I don't have it here. They teach you how to construct or like make a little metal airplane just to teach you like how the equipment in the lab works and how to do things like what order to do things in. Then they give you this task where you have to create this automated guided vehicle. We call it AGV for short. Basically, what it is that it's a vehicle that has a sensor at the bottom, like under the front, and it's a light sensor, so it follows a white line on like a dark material. And this is the main project. So everything you see here was hand built. The wires were hand connected, mostly hand connected. The like this is what the control pad is hand wired. Everything on like the motherboard, I'm not sure that's the right word, but it was all hand soldered, hand attached. If you made a mistake, you had to like take it apart and restart it. The screen you see was all coded by us, the students. We were put into groups of 4 or 5, and it was a year-long project. So we had to do the design, the calculations. Underneath is like a steering pad, so you have well steering a steering control. So we used like what's called a trapezoidal linkage, which is kind of similar to what cars have, but not exactly the same thing. And we had to design the whole thing. So almost every group had different designs. So you have to do the whole thing from scratch. They also teach you how to, well, they teach you how to code the like screen, the blue screen that you can see there. And then on the last week of school, or the second to last week of school, you test it. So they put you on the floor and it's like go forward, turn, like follow the circular line, go forward, go back, and do a 3 point turn, which is what most people struggled with, including my group. But the technician is always there to give you a helping hand. And it was like a really hands-on experience because it, we were in the lab. I think it was like 4 hours a week or something, and it wasn't the only product we had. The other picture you see is circuits from my electronics module. This was more like you had a lab every week, every 2 weeks, and you had to write reports. So it's a usual structure for labs and projects is you do the project, you like plan it out, do the project, and you write a report afterwards. So everything we did, you have to have like a report at the end of it. On this tab was the second year modules. So the little boat here is for the thermofluids mechanics project. And as the name goes, thermofluids, it has to do with fluids like viscosity and such. Here, the goal of this was to design 3D print and like assemble a boat that could travel as fast as possible across 2 meters. So you'd be thinking of the shape of the boat wants to be streamlined to work properly. How will it be printed? How big will it be? Because our boat, it isn't really clear in this image, but because our boat is so big, it was too big for the 3D printer pads in the lab. So we had to print in 2 parts and then tape together and then pretty much hope it worked. Thankfully, it held quite nicely. But at the back of it, there's a propeller. So it's the white is the intake and the blue is the like output. So it sucks up water and pushes it out from the back side, and that's what moves the boat along. And it has to be able to carry the back. It has to be able to hold the weight of the propeller, and there's a battery and like a control tab in there. So it's a bit interesting because we had to do the calculations, make like we had to make an Excel sheet that kind of showed how fast it'd be going when it reaches maximum speed, when it starts slowing down, approximately how long it takes to cross the 2 meters. So this was also a very hands-on project, also group work, but it was interesting. It was fun. I quite like this one. It was like the highlights of my year for this particular thing. And then on the far right is a tank support from strength of materials. So this project was focused on we were given a tank and we're like find the PowerPoint. I said find PowerPoint. I'm sorry. I'm reading trying to read each at the same time. Given a tank and saying that we should design a stand for it and that will carry the weight without bending or breaking or buckling. What do you have here? Would you mind sharing the PowerPoint? I I'll have to ask. I'm not entirely sure if these are going to be shared. I do believe they are because these are being recorded. But I will ask and get back to you on that. Will you say biomedical engineering is more biology, chemistry, or physics based? It's definitely more biology based. Definitely more biology based. Now, it is physics based because we are still doing engineering. So you definitely have that aspect. Like mechanical engineering is similar to physics. At first, it is pretty much physics, but as you go on, it deviates and becomes its own thing. But biomedical engineering is biology. Like, for instance, I guess technically last year in the first semester, we had a module called Immunology and Cell Biology, which, to summarize it, was talking about the immune system, how antibodies are made, how it fights against various diseases, how to make vaccines, how vaccines are best created, and the history behind all that. So, biomedical engineering is definitely biology focused with a lot of physics because it's mechanical engineering as well. Will this field be mainly focused on making devices and drugs or just devices? It's more focused on the actual devices. Yeah, now we learn how, for instance, we learn how the drugs are made, but our main focus is would be like the production of the drugs. It wouldn't be like the science behind like whatever chemical reactions the drugs like induce. It but it would be drug production. What process does it take to get from point A to point B, the final products being the drug itself? I don't think, as far as I know, I don't think we do much in like the chemical aspects of it. So I would say production and devices. Does that answer your question? Yeah, I don't think we do much about just the drugs themselves. No problem at all. Okay, I do believe this closes in about 2 minutes. So if anyone here has any last questions, I'm happy to answer. If not, enjoy the rest of your evening. And thank you for coming.